So the good news for all of you right now is that we're pretty much done with core Docker functionality. So at this point, you're pretty much, I would say, like intermediate users of Docker, which is pretty cool, I think. We're going to get into some more kind of ecosystem type things. So the first thing that we're going to talk about is like multi-container projects, which we talked about networking and how to connect like this container to this container. But can you imagine like trying to get like another developer on your team to try and do the exact same thing that we just did? It'd be like a series of like 9 steps and things would go wrong and be a problem, right? It would be better if we could just give them like, here, run this one command and it's going to set up all the containers that you need. That's what Docker Compose is going to do for us, and we'll talk about that in a second. And then we're going to get into Kubernetes, which deserves 3 courses unto itself. So we're going to do the most basic Kubernetes things so that you can understand what it is and what it does for you. And then we're not going to go any further than that. You'll have to like look for other courses if you really are interested in getting deep into Kubernetes. Lastly, I wanted to introduce you to some non-Docker kind of technologies, and we'll get there with Buildah and Podman, and then we'll wrap up. So let's go ahead and get into Docker Compose. This actually might be one of the most useful things that many of you walk away with this class from. Docker Compose is extremely useful for development environments, less so for production environments, and we'll get into reasons why here momentarily, but suffice to say, most projects have like 1 or 2 servers, or at least 2 plus servers running, right? You have a database, maybe you have 2 services running or something like that. And getting that all set up with Docker, like we saw with the networking stuff, it's possible, it's just annoying. Docker Compose allows you to say, here's this container, here's this container, here's this container, here's how they talk to each other, now spin them all up for me. And then you do it with one configuration file. And then you say Docker Compose up, and it'll do all of that stuff for you. So Docker Compose says on its documentation, it is suitable for production environments if you have like basically one host running all of your containers, which for the most part, most people don't. We have multiple hosts running our different containers, right? And you don't want to be tied to one host. You want to be able to say, scale this horizontally for me. Throw 100 containers at this problem. And you can't do that with Docker Compose. So that's just something to keep in mind. If you have a production environment where you have many containers and you want multiple hosts, your solution will be Kubernetes. And we'll get into that next. One of the most useful things as well for Docker Compose, it's very useful in continuous integration, continuous delivery kind of situations. You can say, hey, Azure Pipelines or Travis CI or something like that, spin up all of these different containers, make sure that all these unit tests and integration tests pass, and then spin it down. Docker Compose is really good at that. So let's go ahead and just get into it. So let's do it from our same networking project that we had. I'm going to stop my server here. If it'll respond, it might not. So let's just go ahead and kill it. I'm going to kill all of my running containers right now. So I'm going to say docker kill db and bold roads. So if I look at Docker PS, I have nothing running right now. Great. And what we're going to do inside of this particular project is we're going to create a new file inside of the networking project, right? It's going to use the same one. And we're going to call this docker-compose.yml. And for me, I get this nice little pink little Docker container. All right. So many of you may not be familiar with what YAML is. If you're not, good for you, I envy you. I'm not a big YAML fan. Other people swear by it, love it. It's kind of like, I call it the Python of JSON, because everything that there's significant white space, and I don't like significant white space. That's just a personal opinion I hold. So we're going to, and we'll walk through what YAML is, but basically it's like JSON without all of the different quotes and stuff like that. So we're going to code together this Docker Compose file. It's going to outline how everything connects to each other, all the various different containers, right? So it's going to say, hey, here's all these various different containers I care about. Here's how they connect to each other. So the first thing you have to identify to it is what version of Docker Compose are you going to be using. So we're going to be using 3. I'm told that version 2 is still fine to use. Like that's kind of counterintuitive for people to think like I should use 3. 3 is the latest one. But version 2, it still works as well. And they actually still maintain version 2 of it as well. I don't use it, so I can't really tell you what the difference is, but it is out there and still works. And then here we're going to say services. We're going to identify all the various different services that Docker Compose is going to spin up for us, all the various different containers. Okay, so this is what I'm talking about when there's significant white space. So I hit colon here, and that means that I'm going to give it multiple things after this, and then you have to indent it here. If you don't indent it, YAML's going to think it's another top-level thing. So we're going to make one called the web container, and we're going to make one called the DB container. The web container is going to be our project that we just coded together with MongoDB. So we're going to tell it where its Docker file is and where it needs to build it, which is here, where the Docker Compose file is. You could also say like ./Docker file. You'd be pointing to where the Docker file is. But if you just put dot, it means it's in this. There's a Docker file in the same directory as this Docker Compose file.
It's going to automatically look for it.
Exactly. You need to tell what ports that you care about. And here you're going to give it like a bulleted list, right? Kind of like Markdown. So we're going to give it a bulleted list of what ports that we want to expose where. There's a 3000:3000. Looks very much like how you would run that with Docker, right? We're going to expose port 3000 on 3000. Here, we're going to do volumes, just like we were talking about before, of how to connect our code to this. So the first thing that we're going to do on this one is we're going to say our code exists at .:home node code. So expose everything inside of our container, like our entire code base inside at home node code. So this is going to mount our code into there so that then we can keep writing code, right?
And that is equals work directory in workdir in a Docker file.
It's like a bind mount. It's a bind mount is actually what it is. And then we're going to tell it that home node code node modules treat that separately. And basically what we're saying is don't bring over the node modules because you need to install it inside of there. And then we need to tell it this is linked, so links, this is linked to DB, which means that I know these two containers need to talk to each other. And the other thing, because it knows links first, it's going to start DB first. Because if you try and start the web service first, it's going to look for MongoDB and not find it, and it's going to crash, right? So it's going to say, oh, you depend on DB. I'm going to start DB first, wait for that to finish starting, then I'll start web, so that everything can start in the right order. And then one more thing underneath links. We're going to give it the environment variable of where to go, which is Mongo connection string MongoDB ://DB :27017. Now you would go do this for all your various microservices or front-end services or all the different containers that you are building and starting up. For DB, it's much more simple. We just need to point it at which image that we want it to run, which for us is going to be image :mongo :3. And that's going to be smart enough to go get that off of Docker Hub, start running it as our DB container. This is another kind of deep rabbit hole of things you can do. Docker Compose can do quite a few things for you. This is pretty much the most basic version of that for this. All right, so where am I? I am in Intro to Containers, so we're going to go back into networking, and I'm going to say Docker-compose, that dash is important, up, So one more thing before we run this. I forgot a leading slash here. So you need slash home node code. So dot, and just to kind of run through that again, the dot here says that this is going to take everything in the directory of the Docker Compose. And you could have done, I don't know, the whole path, which for me would have been pwd. It would have been this, right? So I could have copied all of that and put that right there. I don't suggest doing that because obviously that's very specific to your computer. What you want to say is everything inside of this directory where the Docker Compose file lives, mount that in the container at slash home node code. And I had forgotten this leading slash. Make sure you have that leading slash there. Okay. And here we're going to say Docker Compose up. And this should get our entire environment working. Okay, so you ran Docker Compose up, and you got a bunch of output. And the first thing you'll notice here is all these DB1. So the nice thing about Docker Compose is you can actually run multiple versions of the same container. I'm not going to show you how to do that with Mongo because then you have to worry about sharding and replica sets and primaries and secondaries. But that's what the DB_1 means. It means it's the first of those various different containers running. And this is, if it looks familiar to you, it's all the MongoDB output, right? So you can see here at this point, it actually receives a client connection from driver Node.js, and it's running the 3.3.5 driver, which is one that we installed. It's from Linux, and it's Node.js version 12, which is right? That's the one that we made. And then you can see down here at web_1, this is the output from our server that we wrote. So now, in theory, I should be able to click on this and open this link. And this looks very familiar to, right? This is the other app that we just wrote in networking. So if I go add, and then come back here, notice that everything is working. So these are the logs coming from our Node.js application that we wrote, right, in the previous networking chapter. And if you come over here and do like /add, everything is working the same way expect it, right? So like it's working on port 3000, which is what we told it to do in the Docker Compose file. And if we come over here and say, go to this, you can see count 11, everything's working the same way. But instead of having to connect everything manually to a network and say like, okay, this container talks to this one, it does it on this network, blah, 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 we don't have to do that anymore. We can do that just by making a Docker Compose file that says, this container does this container does this, and these ones are linked together. And then Docker just handles all of the networking business for itself. I'm a big fan, if you can't tell. Everything's working with Docker Compose up. You just share your Docker Compose file with your coworkers, with your teammates, and they can just say Docker Compose up themselves. They don't necessarily have to understand how everything connects together. They don't have to manually interact with Docker networking. Everything just kind of happens for them behind the scenes. Just needs to know how to set it up, and then you're done.